This is our lesson video for day 7.2. We're going to be talking about surface area of prisms and cylinders. We'll give you some definitions here, and there's a lot of new vocabulary for this, but we're talking basically about surface area, which is really just the total area of all two-dimensional or 2D surfaces. Okay? Meaning we take the sum, we add. Okay, we add up all the individual surfaces, all the rectangles, triangles that make up the surfaces of a three-dimensional object, and we total them up. So we have two main kinds of three-dimensional solids that we're going to be talking about today. One of those is called a prism, and the other one is called a cylinder. We're going to talk about other forms of these things later on, but a prism is really just kind of a mathematical sounding word for a box. We're looking at some kind of box shape, but a prism, the definition of that is a solid, okay, meaning three dimensions, with two congruent, symbol for congruent, and parallel bases. Okay, those are polygons. Okay, congruent and parallel. All right. So a solid with two congruent and parallel bases, all the other sides that connect those are called faces, and those will be rectangles. But a cylinder, okay, is really just a prism with circular bases. All right, so the sides that connect those circles form this, what we call a lateral face. Okay, and every prism that we work with has a special kind of name based on what the base shapes are. So in this case, all of these six faces, or all these six sides of this prism, are rectangles. Okay, and you can kind of see that it's drawn in perspective, in three-dimension perspective, but I'm going to use the top and bottom as the bases here, those rectangles. Since the bases are rectangles, this would be called a rectangular prism. Once it's classified, we want to name it as its specific kind of prism or whether it is a cylinder. So this would just be a cylinder. There is no special name for a cylinder. But this is a prism, and the bases are these two congruent trapezoids at this left side and then this back right side. Okay, since the bases are trapezoids, we would call this a trapezoidal prism. And then over here, these top and bottom have to be the bases because they're the ones that are congruent and opposite from each other, exactly parallel. These top and bottom pentagons are the bases. So we would call this a pentagonal or pentagonal prism. So that's how we name these prisms. We name them by the shape of their bases. The bases are always the two sides that are parallel and congruent. And here is a clue. Any surfaces of a prism that are not rectangles have to be the bases. So these trapezoids, they're not rectangles, so they have to be the bases. These pentagons have to be the bases. All right, so when we find the surface area of prism, we are really just adding up all of the individual parts, okay? So the surface area for prism is just the sum of the areas of all the faces. Okay, the faces are any 2D flat surface on the outside of a prism. Okay, so we're just going to add up all the pieces. But for cylinders, we have a specific formula to use. Okay, the surface area of a cylinder has a specific formula, and so we write that as S for surface area, or SA really for surface area, equals 2 pi r squared plus 2 pi r h. I'm going to explain where this comes from a little bit more in class, but basically this 2 pi r squared is because at the bases of a cylinder we have a circle. So there are 2 pi r squareds. There are 2 areas of a circle. Pi r squared is the area of a circle, so that's 2 times that. And then this curved surface, if I were to cut this cylinder apart and open up this surface like that, we would get a rectangle, where this height of your rectangle is the height of your cylinder. Distance between those bases has to be the height of the cylinder. And then when I cut this circle open, this becomes the circumference of a circle, which circumference is 2 pi r. And I'll show you that in a little more detail in class. But this is the formula for the surface area of cylinders. R is the radius of your circular base. H is the distance between those bases, or the distance between those circles. So we're just going to practice finding the surface area of some of these figures. And we're not going to cover all of these. We're just going to do a few, and then we'll do some more in class together. But we're just going to practice using those formulas. So in order to find the surface area of a prism, this is a triangular prism, we're just going to identify the individual pieces and add up their areas. Well, there are 2 triangles and there are 3 rectangles. Now, each of the rectangles has got a different set of dimensions though, so I can't just find the area of one and triple it. I have to find the area of each individual one. So the total surface area is going to be kind of a long equation, but it's just the total area of all the surfaces. Well, we have a rectangle in front, which is 3 by 2. So I've got 3 times 2 is one area. Then I have a rectangle along the back that is also 3 by 2. And then this one along the side is only 2 by 2. But then I have, sorry, I shouldn't have said equal there yet, 2 of these triangles. Now the area of a triangle, remember, is 1/2 base times height. Well, I'm going to call the base of my triangle 3 and the height of my triangle 1.9. So I've got 2 of those. Kind of ran into the other box, but that's all right. Since I've got 2 of those, this 2 and this 1/2 just cancel out. Okay, so I've got 3 times 1.9. Now I'm going to add all these up. 3 times 2 is 6. This other 3 times 2 is also 6. 2 times 2 is 4. And then when I do 3 times 1.9, I get 5.7. Remember, we took half of that, but then you double it because there's a triangle on top and a triangle on bottom. So I'm going to add all those up. And our total surface area for this figure is 21.7 square kilometers. Okay? All right, we're going to skip over this example. We'll cover this one in class. Don't cross it off. We'll get to it in class. We're going to move over here to our cylinder. Since we're dealing with a cylinder, we want to use our surface area formula, 2 pi r squared plus 2 pi r h. Okay? The radius of your cylinder is 5, and the height of your cylinder is 10. So we're just going to plug those in. 2 pi times 5 squared plus 2 pi times 5 times 10. And the calculator will do a lot of that for me. And we should get this total area, 471.2 square centimeters. All right, as we look at these next few examples, we are dealing with composite shapes. Okay, so we're going to do this example in the middle. We'll save the other two and talk about those in class. But composite shapes, again, mean we're just going to add up all the pieces together. And so it gets kind of long to think about, but what we really have is a rectangular prism on the bottom and a triangular prism on top. I want you to think of this triangle at the front as one of your bases of that triangular prism. That means the triangle at the back is the other base. So we've got two triangles. We can assume this is a right angle. So it's a right triangle where this is 3, this height is 4, same at the back as it is at the front. So I can find the area of that triangle pretty easily, but there's two of those. There's a rectangle on this slanted side at the back. There's a rectangle here on this side, but the rectangle along the bottom of this triangular prism would not be included in my surface area because I can't actually get to that as a surface. It's not on the surface, it's inside the figure. These are stuck together. So I don't want to include that 3 by 5 rectangle. So I've got a 4 by 5 rectangle on the side here. Then I have another 5 by 5 rectangle, or square rather, along that slanted side. Then I have 2 of these triangles that are 3 by 4. So 1/2 times 3 times 4. And that covers my rectangular prism. But then I have this, the triangular prism. Then I have this rectangular prism on the bottom. So I've got a 3 by 3 square on the front and on the back. So there's 2 of those. So I can do 2 times 3 times 3, or write it out separately, 3 times 3 plus 3 times 3. Then I have 2 of these on the left and the right that are 3 by 5. 2 times 3 times 5. And then I only have 1 of the 3 by 5s on the bottom. The top, again, is covered up. So there are only 1, 2, 3, 4, 5, 6.
Pause for inability call 225.
Sorry about that interruption. I only have a total of 1, 2, 3, 4, 5, 6, 7, 8, 9 surfaces to include. So this is 20. This is 25. 3 times 4 is 12. And then half and then double cancel each other out, so it's just 12. 3 times 3 is 9, but there are 2 of those, so that's 18. 3 times 5 is 15, but there are 2 of those, so that's 30. And then another 15 at the back. Or sorry, it's actually the bottom rectangle. So I'm going to add those up. It gives me a total of 120 square centimeters of surface area. All right, we've got a few examples here we can still cover in class, but this gets us started with finding surface area of rectangular prisms and cylinders.